Okay, so welcome to today's webinar in our series on the future of AI in education and training. I am Lewis Johnson, the host of the webinar series. I'm very pleased today to have Professor James Lester, the director of the Center for Educational Informatics at North Carolina State University. James and I have collaborated over the years. We wrote a paper this year on pedagogical agents that came out in the AI magazine, and I recommend that article to you. You'll also see some examples of pedagogical agents in James's talk today. But James's main theme today is going to be intelligent, narrative-centered learning environments. These are learning environments that exploit the power of narrative to promote learning. They incorporate elements of intelligent tutoring system technology, as well as elements of game technology. And there's interesting synergies between the two that James's work exploits. So James, we're looking forward to hearing your talk today.
Thanks so much, Lewis. I appreciate the opportunity to share what we've been up to with not only you, but also the webinar audience. So there's been an enormous growth in the power of AI technologies over the last 10 years, and particularly over the last 5 years. And there's been a lot of activity, a lot of focus on this in the public discourse, some of which is positive, some of which is negative. But we're particularly pleased to share today a lot of the work that we've been doing that exploits these really significant advances in AI technologies for the good, and in particular their application to education and to training. So as Lewis said, I run the Center for Educational Informatics at NC State. We're really focused on transforming education with AI-driven learning environments. So this means leveraging AI for many, many different kinds of applications in education and training. And we'll see a good number of those today, particularly those that are focused on narrative. So AI-enriched learning is something that the intelligent tutoring systems community has been pursuing for about 40 or 50 years now. It's been a long time. And it's been particularly gratifying to see the sort of call for these kinds of technologies to come into the classroom. So while we've been looking at this for many years, only in recent years has there been really an appreciation for what these can do. So today we'll be looking at not only what AI enriched learning technologies and training technologies can be like now, but maybe we'll get a little taste of what they might be like in the future. And in particular, we'll be looking at sort of a combination of personalized learning assistance, which we believe can be very powerful for lifelong learning, together with those same kinds of technologies for training, and all in the context of narrative-centered learning. So there's this really rich history of empirical work in the learning sciences and educational psychology communities on one-on-one tutoring. So many lay people may not know that there is an incredibly strong body of evidence to suggest that one-on-one tutoring is really very powerful. So one-on-one tutoring has characteristics about it. We actually don't know exactly what makes it so effective. But it's got characteristics that make it significantly more powerful than what we see in classrooms of 20 or 30 or even larger numbers of kids. So if you were a parent and you had infinite resources, you would hire a tutor for your child, and then there would be advantages that come from the natural language interactions, the affective rich interactions, the incredibly rich problem solving, the motivational impact of tutors. So there are many different components that human tutors bring to the table. And it's very clear that this is a terrific way to go. Unfortunately, it's not an economically viable model. So those of us in the intelligent tutoring community have been working tirelessly to come up with computational equivalents, or sort of near computational equivalents to learning technologies that can do the best that we can to augment learning in ways that emulate one-on-one human tutoring. Now, happily, we're not the only ones to realize that this is really a significant opportunity. The Computing Research Association, which is kind of the major policy arm of the computing community, came out with a sort of call to action for people, computer scientists at large, but in particular people that work on learning technologies. And their call tells us that we, as a society, could really benefit from being able to provide a teacher for every learner, which is super attractive. So it further goes on to say that we would like to let students learn at their own pace. We would like students to receive continuous, customized, and meaningful feedback and assessment. And we would like to let them acquire new skills in a way that's both effective but also engaging. And this is exactly what the intelligent tutoring systems community has been looking at, and also what we've been looking at in narrative-centered learning technologies. In particular, this particular policy piece says that such systems, properly used, can produce a significantly better educated populace by combining advances in learning sciences, that is what we know about how learning works, with advances in information technology. And in particular, what we've been looking at is advances in AI. And one of the things that I have been thinking about a lot over the last couple of years is we see that AI is kind of driven by several different factors. So one is certainly Moore's law is making us race along. There's no doubt that the availability of data is really significantly driving it. And then we see algorithmic innovations in machine learning. Happily, exactly these same factors are in place in AI-enriched learning technologies. So, of course, the hardware is benefiting from Moore's law in just the same way. But we've also got this massive volume of data that's just waiting to be collected. And we'll be seeing examples in narrative-centered learning environments where we can collect that data in a way that just absolutely is perfectly fitted to driving machine-learned policies for controlling narrative interactions to support learning. So we're just at just the right place and at just the right time to make this happen. And what we'll be doing is looking at these AI advances in a way that integrates several different kinds of technologies. So we're trying to not only build on these significant advances in intelligent tutoring systems, but also the significant advances in commercial game technology. So the investment that's been made in the commercial game industry is substantial. And what we as educational technologists would like to do is to leverage these advances and do so in a way that takes advantage of the compelling properties of narrative. We'll be looking at how this might be done. And there's a hypothesis that drives all of this work, and we can think about it like this. So imagine that we had technologies that could have a couple of components to them. So the first of these would be intelligent story. We'll talk about what intelligent story means today. And pedagogical agents, which is a family of functionalities that are embodied. And pedagogical agents have been the subject of not only significant attention in education, but also training by companies like Alelo. And by marrying these technologies of intelligent narrative and pedagogical agents, what we anticipate seeing is very strong cognitive support for learners. So being able to support problem solving, being able to support metacognition, being able to support the acquisition of not only concepts, but application knowledge. And this is something that the intelligent tutoring systems community has demonstrated widely over dozens, hundreds of studies over many years now. But we would also like to see the potential benefits that we might get from intelligent story and pedagogical agents with respect to motivation. So especially for young learners, it's very important to motivate them, to really help them understand the importance of what it means to pursue a problem, even when it gets very hard. And being able to confront these kinds of challenges is something that is a skill itself. And then what we expect to see is an improvement in growth mindset. We expect to see an improvement in interest, and I mean that in sort of the technical meaning of interest. That is, that we'll see significant increases in students' interest in STEM per se, and hopefully even increases in interest in STEM careers. And together, we would like these, and we expect to see these, leading to increasing persistence in students. Now, we know that this itself is a metacognitive skill, that if we can properly take advantage of it, that together with the cognitive support, this could really produce fundamental advances in learning. And that's what really drives the work that we're going to be talking about today. So StoryCentroid Games represent a particularly interesting genre of games that combine several different elements. So what we're really trying to do to begin with is to enable learners to participate in what we call story-centric problem-solving activities. So we would like the problem-solving activities to be so intricately and integrally related to the story elements that you can't tell where one begins and the other ends. And we also want to create experiences that are immersive, that is, where the students are completely fully present in the narrative experience and the narratives themselves being tailored for those particular students. And narratives take on many forms. So most of us are familiar with narrative in prose and narrative in film, but interactive narrative typically has believable characters, that is characters that exhibit features that makes us believe that in some sense they are real. They have perhaps a backstory that drives this. They have their own goals. They're trying to achieve these goals in a potentially very complex story world. These activities, the story activities, are playing out in, we hope, very rich virtual worlds. And the stories themselves often have fairly complex plots that drives the problem solving. We'll see some examples of this today. One of the very important characteristics of story that appears to be one of the factors that make them so well suited to learning is that these are affect-rich phenomena. So we've known for a very long time that there is a very complex interplay between affect and cognition, not just in problem solving as a whole, but in learning in particular. And we know that performance affects affective states. So if a child performs well, they're going to be in typically very positive affective states. If they encounter some problems that they're not able to overcome, that puts them in negative affective states. But more important is that affective states affect performance. So if we're able to monitor the affective states that students are in, whether they're frustrated or whether they're confused or whether they have some curiosity to their take on the current story situation, that can significantly affect their performance. So what we're trying to do is take advantage of this very tight loop, this almost inseparable relationship between cognition and affect. So what does it mean to support affect? Well, affect is clearly a very natural component of tutoring. So first-rate tutors, and in many countries, tutors are the rock stars of the education world. So first-rate tutors are extremely attuned to the affective states of their tutees. And because affect is a keystone, really a kind of fundamental core component of effective learning, if we can support affect, that is, if we can create stories that have characteristics that on a kind of ongoing moment-to-moment basis can support affect, then it could really be a win. And we're interested not just in short-term effects. So short-term effects are terrific. But what we would really like to see are much longer-term effects where we're being able to increase the motivation for learners to engage in learning over very long periods of time. So not just a day or a week or a month, but really for a lifetime. And in parallel, we would like to increase their self-efficacy for learning. That is, their confidence that they're going to be able to be successful in, for example, the complexities of learning new computer science concepts. And this is what we think narrative really brings to the whole learning enterprise. Now, we've been talking about narrative, but the work that we do is actually kind of at the intersection of intelligent tutoring systems and narrative. So this means we're going to have characters that are affect-rich as we're looking to the future. You can imagine virtual humans that have very sophisticated models of affect that enable the characters to respond in a very granular fashion to the affect that the students or the trainees are exhibiting. We can imagine that the problem-solving guidance itself can be incredibly deeply contextualized, so not just sort of overall tutorial strategies, but very minute feedback that's being delivered. And in what is a kind of larger picture functionality, we can imagine that the problems themselves are being dynamically selected. And in narrative, that means selecting narrative episodes that are really appropriate for exercising a particular skill, for example, that we want a learner to master. And it means tailoring the explanation. So one of the real interesting capabilities of pedagogical agents is providing explanations that are tailored to individual users. And doing this in the context of story, we believe can make it even more powerful. So an example of a narrative-centered learning environment that we feel is kind of a prototype for what narrative-centered learning is and can be is called Crystal Island. So Crystal Island is a narrative-centered learning environment that focuses on 8th grade microbiology. So it's aligned with the North Carolina Standard Course of Study as a North Carolina public institution. We do many, many studies with the North Carolina school system. And so alignment either with a particular set of state standards or national standards is particularly important as you're either creating new narrative-centered learning environments or considering them for adoption in your school system. So the story of Crystal Island is that you as the player, you as the learner, arrive at the island and you discover that there's an outbreak on the island on the part of your research team. So one by one, members of your research team begin falling ill. They start exhibiting symptoms that suggest that it could be any number of possible causes. And so the task that you as the learner are given is to identify the illness that's caused this and then to recommend the treatment. The reason I say that this particular narrative-centered learning environment is kind of a nice example of what story-centric learning might be is that we've been working on it for a very long time in our lab. There have been many, many, many major iterations of this game. And it's been the subject of studies, lots of super controlled studies in laboratories. We might talk about some of those today, but also in classrooms. We believe it's very important to really consider the kind of serious practicalities of what it means to do classroom implementation. So we've looked at Crystal Island in classrooms that are maybe 30, 40 kids, but we've also done whole school implementations. We've even done whole district implementations. Crystal Island's been used by learners from all over the United States. It's been used internationally. and we would be delighted to share it with you. So if you are a school superintendent or a principal, assistant principal, a teacher, a parent, and you would like to use it, please drop us a note. It's free, and we're always delighted when people take advantage of what we believe is a very engaging set of learning interactions that Crystal Island creates. The particular version of Crystal Island that we'll be looking at today is called Crystal Island Loss Investigation. So a few years ago, the Gates Foundation, together with the Hewlett Foundation and EDUCAUSE, funded some work that we did on integrating game-based learning for science education with game-based learning for literacy education, all under the umbrella of narrative. This turns out to be a really interesting kind of laboratory for studying interactive narrative and narrative-centered learning, because it's really a very complex sort of curricular problem presented. So it means that as the designer, we had to develop techniques, narrative-centered learning techniques, that would simultaneously support learning of complex science, and that's not just the conceptual content, but it's also the differential diagnostic skills that go along with solving the science mystery, together with the literacy education work. So when people think of literacy education, they typically think of kind of introduction to reading that we see in the very early grades. But this particular project focuses on complex information text. And not only kind of in the abstract understanding complex informational text, but also being able to comprehend those texts and apply the content of those texts immediately to problem solving. And we'll see how that plays out in Crystal Island. The second major goal here was really to create an implementation program that is a kind of full package for deploying Crystal Island in middle schools. So there's a rich body of professional development materials that are also available that were created in this project, and those are also free. We're delighted to share. So let's take a look at a little video of how narrative-centered learning plays out in Crystal Island. So you can see there are many, many elements that go into making a narrative-centered learning environment serve these two goals of being effective and engaging. And one of the most important kind of meta findings of this work is that it takes so much focus grouping and so much piloting and so many cycles of iteration to really hone the experience that the learner has. And of course, these are different from different grades. I'm only showing the 8th grade version. We have a 5th grade version for maps and landforms that has similar characteristics. And these are unanticipatable at the beginning. So it's a very empirical kind of development cycle. One of the things that I think is really important is that every single game element in a narrative-centered learning environment really needs to serve two roles. One of these is pedagogical, so it really needs to support learning, whether it's conceptual or problem solving or metacognitive. We have several projects with our colleague Roger Azevedo at the University of Central Florida that looks at metacognition and self-regulated learning. And so driving pedagogical goals is important. But we also have to have narrative elements that are driving story goals. And it's so important that both of these be really, really carefully aligned because otherwise we end up having this sort of chocolate-covered broccoli that we see with poor designed game-based learning environments. And by having a story at the center, it actually is possible to have both the narrative and the pedagogy being served at the same time. There are many, many different forms of narrative-centered tutorial events that go on in the game. In some versions of Crystal Island, there are side quests. This is a way that we've learned we can deal with remediation in a kind of seamless fashion. We've also done a lot of work on embedded assessment, in particular looking at stealth assessment techniques for being able to formatively assess the particular knowledge or skills or sometimes misconceptions that students may have, and doing that in such a way that ultimately we believe will be very useful for not only driving scaffolding within the game, but also driving interventions in the classroom by students. And we'll talk a little bit about that. It's also very important to tailor these sequences of embedded assessment. So one of the things that we found is if you have rich trace data, and this is something we'll be talking a lot about, it's possible to even think about what order embedded assessment should be sequenced in. In other words, the diagnostic information that's provided by particular kinds of assessments can be ordered in such a way that we get the most sort of informative assessments early, and then we can tailor the rest of them as the learning session unfolds. So in Crystal Island, as in other well-designed learning environments, there's a very complex physical environment that is explored. One of the design lessons from having done this for a number of years now is that the complexity of the environment has to be designed with the learner in mind. So in very early versions of Crystal Island, the environment was actually much larger, though somewhat less complex. And what we found is that students spent too much time sort of navigating and exploring this very interesting environment. So what we believe we have now is kind of a sweet spot of size of environment without devoting too much time to sort of physical movement within the environment, but coupled with lots of very well-placed narrative elements that create engaging experiences. Throughout Crystal Island, there are posters and other resources that contain content knowledge. So these are placed in such a way that students can kind of notice it, and then they'll take the time to look at it. We've, in the last couple of years, started doing some work with eye tracking and gaze. So it turns out that gaze is kind of a nice proxy for attention. And so we've been looking at gaze-based studies to investigate what's the best placement of resources like this. How much time do high-performing students spend on these? How about low-performing students? Are there kind of nudges that we might want to make to low-performing students based on where they're looking, for example, at these resources to convert them to high-performing students? We also have lab equipment. So as I mentioned, this is a deep diagnostic reasoning task that takes a considerable amount of kind of iteration on the part of the student through the data collection cycle, the hypothesis formulation piece of that, managing hypotheses, and so forth. And one of the findings from many studies is that it's proven to be very important to develop cognitive tools that can support students in these complex diagnostic reasoning tasks. So here we see the diagnosis worksheet. This is a very compact device that we've crafted so that students can, in a very quick, efficient way, keep track of all of the data they've collected and the possible explanations that they're considering for the data, and also to record their diagnosis. We also have, throughout the game, another set of resources are the complex informational text. So it turns out that being able to integrate these complex informational tasks into the story has been a major win because by requiring students to read these texts in order to understand the content, in order to get past the next hurdle in the narrative plot, it's sort of killing two birds with one stone. So it's getting the reading, but it's also ensuring that the content itself is integrated into the problem-solving process. There's a lot of elements to Crystal Island, a lot of visual elements that make it a deeply engaging experience for students, and I would encourage our viewers today to check it out. There are also concept matrices embedded throughout the game. One of the interesting aspects to Crystal Island is that sort of in some ways unbeknownst to the student, they're constantly being assessed. So this is all done under the guise of kind of filling out some paper that's been left by members of the research team before they fell ill. But in effect, these are very cleverly designed assessments that are giving us information about what kinds of issues the students may and may not be having problems with. One of the areas I think is particularly important for future work is character dialogue. So my own technical background is in natural language processing, and we really have not done a huge amount of work in NLP. We've done some. In fact, we just wrapped up a project in this area, but I think that the potential for NLP and for speech reco and text-to-speech is very significant, and we're going to start seeing the appearance of pedagogical agents that are incredibly rich in their ability to communicate. The project I was alluding to is one that we just finished up with colleagues Christy Boyer, Brad Mott, and Eric Wiebe, where we looked at affect. So we're particularly interested in what does it mean to have what we call an empathetic learning companion that can respond to students in such a way that it emulates what empathy is like in human-human interactions. So in this project, we looked at things like being able to monitor the level of frustration that a student might be experiencing, and then using the dialogue and what we know about their affective state to intervene not only cognitively, as we've discussed, but also addressing motivational issues and affect issues. A very interesting technique that's often used and has proven incredibly helpful in work on pedagogical agents and narrative-centered learning environments are particularly well suited to this. It's what we call Wizard of Oz studies. So this is where we build an initial version of the narrative-centered learning environment, and we have students begin interacting with a learning environment. But what the students may not notice is that the pedagogical agents are actually not driven by AI, as they will be in the final version of the system, but in fact they're being driven by a human wizard who is controlling all of the, certainly all of the utterances of the agent. Sometimes we go broader though. Sometimes we have the human wizard controlling narrative events in the game. So for example, initiating a particularly significant kind of reveal in the game about the source of the outbreak if the student is having too much trouble, or causing a particular test to have a particular outcome if that might kind of guide problem solving in a productive way. These Wizard of Oz studies turn out to be really useful. And the thing that's a little bit surprising, I don't think anybody would have thought of this 20 years ago, all the data that's being collected from these Wizard of Oz studies is the perfect set of training data for a machine learning algorithm. So by being able to collect this enormous amount of data, not just the exchanges between the student and the pedagogical agent, but also this very rich set of information, video, GSR, gestures that the student might make, where the gaze is, all of this prosody provides an enormous amount of information, not only about what the student is doing, but the context in which they're doing it. And the wizard is in essence providing a sort of exemplar of how a very smart AI might orchestrate the events in the narrative. So that data can then be used to machine learn models for learning when to initiate tutorial events in stories, and also how to initiate tutorial events in stories. And this has been an enormously effective approach. Dialogue act modeling itself is really interesting. So one of the things that we've been investigating in lots of different ways over the past maybe 4 years now is looking at the integration of these multimodal data streams. So there are practical issues that arise in this. One of them is synchronization. So when you have a bunch of different devices running on a bunch of different machines, you really have to consider the clocking of these things. And it sounds like in some ways not a particularly interesting problem, but it's a really critical problem, something that kind of has to be solved very, very carefully to ensure that the data streams are compatible and packaged in such a way that they're ready for consumption by the machine learning algorithms. We talked a little bit about assessment. We've done this work in classrooms, which is interestingly much more positively received by students, I think, than a lot of tests, because they don't even realize that as they're having an engaging interaction with a character or solving some episode of the game, that they're actually being assessed. So it's a very comfortable environment for everybody. I sort of alluded to analytics. I think one of the really big potentials for narrative-centered learning that we have just barely scratched the surface of is looking at analytics that are driven by narrative-centered learning interactions. So enormous amounts of real-time trace data. And I kind of mentioned cognition, but there's also a significant motivational and affective set of components. As well as metacognition, for example, our work with Roger Azevedo in studies where we've been looking at reflection and planning and monitoring and so forth. And one of the real strengths of narrative-centered learning analytics is that it really sets the real possibility that we're going to be able to scale these things. Another example, just to explore the space a tiny bit of narrative-centered learning, is a project we've been working on for about 5 years now. So this is a narrative-centered learning environment for computational thinking. Now, while computer science is very important for computer scientists, we believe, and it's widely recognized, that we really need to expose and cultivate much younger students, certainly high school. This particular project focuses on middle school students to computational thinking. So looking at fundamental constructs like iteration and conditionals, assignment statements, those kinds of things, but doing it in a way that's not kind of decontextualized, but rather in a way that's deeply embedded in what turns out to be a really interesting story. So Engage is it's designed for middle school students, as I mentioned, but it's set in an underwater research station, and we currently have about 10 hours of gameplay in Engage. And in our current project, one that we've been working on for a couple of years now, we're looking at the deep integration of computational thinking with science education, so that computational thinking is part and parcel of students' engagement with science. So we'll see a quick example of what Engage looks like here. So this has been a particularly fun project to work on, and sometimes you just sort of hit the sweet spot of some narrative-centered learning elements. And our sense, just having now investigated this in classrooms for something like 3 or 4 years now, maybe 5, is that this is it. So we're really looking forward to getting the publicly available version of this, and are very excited about scaling it. So stepping back, story is kind of fundamental components of human life. So we're wired to both understand and be driven by narrative events. It's kind of a foundational episodic cognitive capacity that we have. So what we're really doing here is kind of reformulating the design challenge to integrate affect-informed AI with game-driven interactive narrative, and doing this in such a way that when it works, it creates learners that are both highly motivated, but are experiencing highly effective learning experiences. So what I'd like to do is to quickly touch on kind of a broad range of interactive narrative, both research issues, but also interesting applications that I think will give the audience a taste of really what the potential is here. We've been doing a lot of work with the Army Research Lab on intelligent narrative-centered training. So here we've looked at the role that affect plays in combat medic training, for example. And it turns out that for very stressful training situations, particularly in the context of narrative episodes that are terribly graphic, and as I said, very stressful, being able to detect the affective states that users are in, and then being able to, in the future, modify the narratives in reaction to these affective states. That's something that we're very excited about. Affect has this very tight loop. So computational models of affect run from affect reco to affect understanding to affect expression. And interactive narrative really lends itself to not only kind of studying these things, but also narrative pushes on the sort of elicitation of this wide range of affective states. A project that we've just begun, this is for NIST, is I think going to be particularly exciting because it combines narrative with VR. So here we're looking at building intelligent user interfaces for first responders who are again responding to these incredibly time-sensitive needs in very, very stressful work context. And we believe that narrative can be especially helpful here. We're also working on a project for the Army called DeepGen, where we're combining reinforcement learning with narrative to automatically create training scenarios. And this is something that's very much the holy grail of interactive narrative. It's sometime out, I think, but we're starting to see the appearance of, and I think we will even in the next few months, see the very, very early versions of this being able to generate narratives in large numbers and having a system that can automatically select the narratives. We're also interested in kind of the interaction between the generation of these narratives and trainers that might pick particular families of narratives that look like they might be especially helpful for the trainees that they're currently working with. Lots of really big, interesting questions in narrative-centered learning. So we've got narrative tutorial planning, that's interactive narrative. We've got the real-time version of interactive narrative. Goal recognition, this is particularly interesting, I think, because one thing that tutors are excellent at is being able to automatically recognize the goals, the intent, the plans of their students. And we've been working for almost 10 years on goal recognition using many different kinds of computational models. Most recently, we've been using deep learning models, and these have achieved accuracies that are much higher than those that have come before. Also, off-task behavior, so building off-task behavior detectors, we think will be especially important. Modeling self-regulated learning, note-taking embedded in interactive narrative, and then studying presence. Which turns out to be very important, and I would also say manipulable. We did a study at the middle school level several years back, replicated at the high school level, which found that a slight modification of the empathetic responses of pedagogical agents can actually statistically significantly affect user sense of presence in the environment, which is, I think, a really interesting finding and has very important design implications. We've mostly been talking about today narrative for formal context, that is classrooms, schoolhouses, and so forth. We've been working for some time in interactive narrative in informal context, in particular with North Carolina Museum of Natural Sciences. So with the Science Museum there, we've been developing a sustainability education interactive narrative that runs on a tabletop. So Future Worlds, these days, we just began a project a few months ago where we're looking at studies of visitor engagement, and really three components of that: cognitive engagement, so sort of problem-solving side of engagement; affective engagement, so what does it mean to emotionally engage visitors; and also behavioral engagement. So people often talk about sort of rings of engagement around exhibits, and we're really interested in studying these three kinds of visitor engagement, and in particular doing so with multimodal data streams. So we're, as I said, just kicking off a project looking at motion tracking, conversation, facial expression, gaze, visitors' gesture, game telemetry, in addition to what are often sort of classic museum visitor studies instruments. And then taking an incredibly strongly data-driven approach to this. So it's a very empirically oriented project, which we believe at the end will yield the first computational models of visitor engagement, and we'll have done so in a set of interactions that are not just sort of solo, but actually collaborative. A completely different domain of interactive narrative that we've been working on for about 5 years is with our collaborator Elizabeth Ozer at UC San Francisco's medical school. So here we've been working on behavior change. Elizabeth is a specialist in risky behavior for adolescents, risky health behavior for adolescents, focusing on alcohol use. So we've been developing an interactive narrative. It's been significantly piloted over 5 years in the Bay Area, where it's in some sense training adolescents to effectively navigate social situations around alcohol use. And that is kind of a nice exemplar of what does it mean to do interactive narrative for health-related kinds of applications. Wrapping up, I'd like to quickly mention work that we're just kicking off with our collaborators at Indiana University. So this is Cindy Mello-Silver, Krista Glazewski, and Tom Brush, where we're building intelligent augmented cognition for teachers. So this is a system that will take interactive narrative in the classroom, and interestingly, this is actually collaborative interactive narrative. So students will be playing Crystal Island in a multiplayer version in the classroom, and we're going to be intensely instrumenting the classroom to deeply understand what does it mean to have an effective learning orchestration by teachers of classroom activities. And ultimately, what we believe this will provide is a system that can support teachers in kind of 3 different modes. So first, before the class begins in a kind of perspective fashion, so planning lessons and so forth. Concurrent, so here we're looking at what does it mean for teachers to be able to take this real-time information about classroom activity, for example, which groups are doing great and which ones might really benefit from him or her intervening, and then kind of post hoc or retrospective, where students, rather teachers, reflect on what's gone well and what's gone not as well as they had wished, and how can we improve their experience for tomorrow. So the future of interactive narrative is incredibly bright. There's this amazingly wide open vista combining lots of different technologies like intent recognition and tutorial dialogue and self-regulated learning and computational models of affect. And we've really, as a field, I think, arrived at the point where we're incredibly well positioned to scale these technologies. So by collecting enormous amounts of data, what we're really doing is enabling the machines themselves to be able to craft interactive narratives that are deeply, deeply personalized for individual students, but to do this on scales that were before completely not imaginable. So to wrap up, personalized learning really has serious problems associated with it. But narrative-centered learning environments hold an enormous amount of promise, and not just for in-classroom, where we think it's significant, but also out of classroom. So for example, in museums and science centers and even home. And by kind of coupling the cognitive side of things with the affective side of things, we have enormous promise for personalized learning. And the real beauty of this approach is that narrative-centered learning has incredible potential for really delivering these kinds of results, not just in a single classroom or even a single school district, but actually fully at scale, even nationally or internationally. So with that, I'd like to wrap up and thank all of our collaborators and our sponsors who made this work possible.
Thank you, James. So again, participants, if you have questions, write them into the chat window. In the meantime, I got a couple of questions. So James, if people want to see more of your work, do you have more videos on your website or in YouTube?
Absolutely. So cei.ncsu.edu. Lots of material about the projects, particularly if there are researchers that are interested, or teachers that are interested, or administrators that are interested, maybe looking at this for their districts. Lots of material there, and please don't hesitate to reach out.
Great. So it's clear from this the potential value of narrative in engaging learners. But one potential risk of narrative is that because it's linear, that students might want to go through it once, and then when they get to the end, then they think they're done. So how do you design for replayability and in extended seat time in your narrative environments?
Yeah, this is a super important question. One can certainly imagine creating an interactive narrative experience that is a one-time and done, but that's considerably less attractive both from a research perspective, but also from kind of a practical perspective of wanting to create learning experiences that are deep. And deep sort of requires extended and replayable, as you say. So the way that we do this is that the interactive narrative itself is different every time. So as we, for example, in Crystal Island, we start the system, we don't know what will be the cause of the outbreak. We don't know what will be the transmission vector. So these are actually selected randomly by the system. And it's also important to note that, at least for Crystal Island, and I believe this is true for interactive narrative in general, it's really important to have what we call an ill-formedness to the narrative space. That is, we want students to be able to pursue many different possible paths to a solution, and we want there to be many possible solutions. So the kind of combinatorics of these factors causes the space to be really quite large and therefore replayable. I should also say that for some kinds of applications, it's very important that students master, and I mean that in a sort of technical mastery learning sense term, the content knowledge. And being able to do that means having kind of challenge versions of the game that might have time pressure associated with it, or different kind of narrative tropes that really require a sort of repeated and intense exposure to the subject matter. So there's a pretty big toolbox of techniques for delivering replayability.
So I think it's very important, the work that you're now starting to do of getting teachers involved in these narrative environments. A couple of issues that I see coming up here is that teachers might feel like, well, there's all this activity going on and it's burdensome to be monitoring all that, and the system is generating all this data and it takes too much time to be sifting through that data. So what are your thoughts about making the teacher's job easier, not harder, as they get involved?
Absolutely. If the technology doesn't make the teacher's job easier, it cannot be used. Maybe in some very specific kind of laboratory setting, the tech might be used, but certainly not in any kind of wide-scale adoption. So what we do is we deeply involve teachers with every aspect of the project. So at the beginning of any project, we will run a series of focus groups, not just with students, but with teachers. And particularly for projects like IACT, where we're looking at developing very rich cognitive assistance that can, in real time, provide support. Our vision is not one of teachers reading an incredible dashboard filled with data, but rather the sort of unobtrusive kind of tapping on the shoulder that a cognitive assistant might do, and suggesting that the teacher might want to pay particularly attention to one student who, for example, might have reached an impasse, or another group of students who, in fact, are doing great and need some enrichment attention. So we think of it, although under the hood, it's absolutely incredibly data-driven. On the front end, it's incredibly user experience driven.
So you've been working with learners at different ages, middle school to adult soldiers. And how does your approach differ when you're dealing with different age groups?
Right. It's often really one of complexity. So one of the kind of fundamental findings of educational psychology is looking at seductive detail. So any kind of learning technology is likely to be prey to seductive detail. That is, details that are really perhaps interesting, but not really critical for learning. And so one of the sort of gotchas of narrative-centered learning, if you don't have a very strong design experience in this area, is you can populate an incredibly rich story world, but do so in a way that doesn't support learning. It makes for a very engaging experience, but not one that's effective. So we find that this seductive detail issue raises itself in different ways for different age groups. And in particular, the kind of complexity, the amount of detail, the amount of realism, you might say, that would be incredibly appropriate, if not absolutely necessary, for training applications, is sometimes not only not necessary, but actually harmful for younger age groups. So that's why more kind of cartoony, simplified sorts of interactions are much more effective on the whole. And also being mindful of the story space itself, which is something that's a little hard to describe if you haven't had experience designing narrative-centered learning environments, but it's kind of the universe of possible events that can transpire in the world. And so limiting those in ways is also a student population specific kind of design criteria that's very important.
Thank you. Okay, well, we're at the end of our hour here, so we will have to bring this to a close. Thanks again, James, for a great presentation. Our next webinar in this series is going to be by Rose Luckin of University College London. She's going to be talking about machine learning and human intelligence and the future of education in the 21st century. I'm really looking forward to that talk, and I hope you are as well. So until then, bye for now, and we hope to see you at the next webinar.